Now I recommend that you go over this review sheet again, at least twice. Go over it on your own at least twice. And I found that the students that do the best go over the review sheet at least twice. And I've seen students bring their grade up in a whole letter grade by from doing that alone. So I highly encourage that. Okay, so here's our review for the final exam, and we'll just go through the questions. And also keep in mind, I have a video already on reviewing for the final exam, but I'm recording this one as well, and then I'm going to compare which one's the better one and go with that, or maybe post questions that are on one that's not on the other, and so on. Okay, so we're going to go through the questions and see if anybody has any questions with that. If there's no questions, we'll just continue on. Okay, problem 1. Any questions with that? Determine whether the relation represents a function. If it is a function, state the domain and range. Questions with that?
No, sir.
All right, move on to number 2. Oh, I got to bring it to my back. Okay. We just looked at question 1. We just started the review. And do you have any questions with problem 1?
No, sir.
No. Okay. 2, find the value.
Yes, sir.
Okay.
I need help with that. Number 2.
Oh, you do want that one. Okay. All right. So we want to find f of 0 when f of x equals to the square root of x squared plus 2x. Okay. Now, you would think. Now, what I found is that I used to do like multiple questions on a test with the same problem. And what I found was that students were getting the hard part right, but this they had trouble with. So if you have trouble with that, no problem with that, because you're not alone. Okay, all we're doing here is we're just substituting in 0 in for x. So it's like we're cutting out the x and we put parentheses. So this would be f of 0 equals to the square root of 0 squared plus 2, or parentheses, and then 0 parentheses 0 times squared, and then 2 times parentheses. And then we're going to substitute wherever x was, we put 0. Okay, so this is 0 squared. Well, 0 times 0 is still 0, right? And then 2 times 0, that's 0. So 0 plus 0 is 0, and the square root of 0 is 0. Okay, and that's all there is to that question. Not anything. Sometimes students will read more into a question than there is, and sometimes it's pretty, just straightforward. Alrighty. All right. Any questions there?
No.
Okay, good. All right. So now, find and simplify the difference quotient. And the difference quotient is f of x plus h minus f of x over h. Now this is extremely important concept, because it's gone over quite extensively in calculus. If you go on to calculus from there, maybe slightly different format, but it's basically the same thing. Okay, so any questions with this?
Yes, sir.
Alrighty. F of x equals to 2x minus 6. And the difference quotient is f of x plus h minus f of x all over h. All right, so there's 3 steps basically to this process, and you're following the formula. So the first thing we need to do is figure out what this f of x part is. Well, sometimes they use f of a instead of f of x. They use a different variable, but it's still the same thing. So basically all this is just rewriting the original equation. Okay, so that's step 1. Okay, step 2, we want to find what f of x plus h is. So we take the original function, and it's like we're cutting out the x and putting parentheses. Okay, so we cut that x out and put parentheses, give yourself a little room, equal to, make that a little bit clearer looking, equal sign. 2, and then where the x was, we put parentheses, minus 6. Okay, and then where the x was, we put x plus h. So we put x plus h and x plus h. H. That's an h. X plus h. And so now we simplify that. So we have to distribute the 2. And so that's 2x plus 2h minus 6. And the parentheses goes away. Okay, so now we take these 2 things, these 2 equations, and we substitute them back in. But you have to be careful here because you're going to cut this out and put parentheses, because you have to distribute this negative into this entire second half of the difference quotient. So down here we'll put parentheses minus parentheses all over h for our difference quotient. Okay, and that's down here. And so now we're going to put in the whatever f of x plus h is, which is down here, 2x plus 2h minus 6, 2x, or 2x plus 2h, I think I said minus, 2x plus 2h, yeah, minus 6, no, I said it right. And then the second half for f of x, we're just putting in the original equation, 2x minus 6. 2x minus 6. Okay, so one of the issues that's common issues that students have is they don't distribute this negative. Okay, so you got to distribute it, and so that's going to change the sign of everything. So once you distribute it, you can drop all the parentheses. So this will be 2x plus 2h minus 6 minus 2x, and then a negative times a negative. So this is like a negative 1, right? Negative 1 times negative 6 is going to be a plus 6. So put a star on that, because that's where students tend to have some trouble, all over h. Okay, so from here we want to combine like terms and simplify and so on. So we have a positive 2x and we got negative 2x. We want to combine those. Well, positive 2x and negative 2x, they go to 0x. So we can cancel those out. We got a positive 2h. There's no other h's, so we leave that alone. We got a negative 6 and a positive 6. They go to 0. They cancel out. Excuse me. So now we're left with 2h over h. And from here we can simplify the h's. They go in each other, so they go to become 1. So that's like 2 times 1 over 1, and that's just 2, and that's our answer. Okay, so another common error that students make is they want to cancel here. They want to simplify the h's here. Well, you can't do that when you've got plus or minuses. And if you had another h in there, you'd have a problem. This time we only had 1, so it wouldn't have mattered. But you don't want to do that until you have only multiplication and division before you can divide. All right. Any questions with that? All righty. Okay. Moving right along. Find the domain of the function. Any questions with that one? Number 4. If you don't say anything, I'm going to think that you don't have questions, and I'm going to move on.
Yes, sir.
You do? Okay. Let's go over, so let me rewrite this. G of x equals 2x over x squared minus 4. All right. So let's go over the concept of domain in its entirety. All right, domain. I like to look at domain to start off with as all real numbers from negative infinity to infinity, except 2 cases as far as the problems that we're working on.
If x is in the negative or x is in the radical.
Yeah, if there's x's in the denominator, right, or negative exponent, 1 over x, and when x is
in the
radical, right? So in other words, if x is 1/2, which is the square root of x, and it has to be an even root. If it's an odd root, that won't, that there are positive and negative odd roots, but even root, and our questions that we're working with, we're only working with even root, square root anyway. So if you want to find the domain for x in the denominator, set the denominator equal to 0, then solve. For the radical, set the radicand to greater than or equal to 0, then solve. Okay, so in this case, we're looking at 2x over x squared minus 4. So we assume that it's all real numbers unless there's an x in the denominator or x in the radicals. So do we have either one of these cases for our problem? You ask yourself, is x in the denominator?
Yeah, it's in the denominator.
Yeah, it is. Yeah, good. So we take the denominator. Set it equal to 0. So this is x squared minus 4 equals 0. And you can either factor it or apply the square root method here. So we'll go ahead and use the square root method. So we solve for x squared. We apply plus 4 to both sides. And we get x squared equals to 4. And then we have to isolate x further. So we have to apply the square root. Well, this method is convenient, but you've got to remember to use plus or minus when you're solving for x, because if you don't, you only have half the solution. Okay, so that leaves us with x equals to plus or minus 2. Okay, so therefore, our domain is all real numbers except where x is plus 2 and a minus 2. Because if you put a positive 2 in here, 2 squared is 4, 4 minus 4 is 0, you get 0 in the denominator, and that's undefined. Same thing if you use negative 2. You put negative 2 in there, negative 2 times negative 2 is 4, 4 minus 4 is 0, you get, in this case, you get negative 4 over 0, and that's undefined. So what that does is it puts, negative holes in our domain. So everything is a solution except at negative 2 and positive 2. So the domain, and this book uses set notation, is the set of all values in set x such that x does not equal to positive or negative 2. And that's our domain. Okay? Questions are. Alrighty. Okay. And so you do the same thing as if there was a radical, and you would solve it the same way. All right.
Yes.
Okay.
Yes, sir.
Determine algebraically whether the function is even, odd, or neither.
Because it's an exponent.
Um, well, now, this one, if it's a single term like this, yeah, you could look at the exponent. But if it's more than one term in it, then that's not necessarily the case. So looking at this one, you probably would know that this would be an odd term, right?
Yes, sir.
But to determine algebraically, let's go over this real quick. What you do is you put negative x. You cut that x out, put negative x in there.
Yes, sir.
So you put parentheses, and then you put negative x in there. Negative x, negative x. And you get negative 4, and negative x times negative x times negative x is still negative x. Negative x cubed. So negative times negative is a positive 4x cubed. Okay, so how do we know if this is algebraically, if this is even, odd, or neither? If we substitute negative x in and basically we get we get x out. In other words, no signs, after we simplify, no signs change, then it's classified as an even function. Well, what would be considered that? Well, if this was 4x squared, for example, and we substituted negative x in there, and negative x squared times negative x is just x. The negatives cancel, and you end up with 4x squared. You get the original function, no signs change. Then this function is even. Okay.
Yeah.
If you substitute negative x in, and you get basically all signs change. So in other words, it's like you're distributing a negative into the entire function, and all signs change. Then it's an odd function. Okay, and then if you substitute negative x in, and some signs change and some don't. Some signs change and some don't, then it's neither even nor odd. Neither even nor odd function. Okay? All right. So that's a quick lesson on determining algebraically if a function is even, odd, or neither. All right. Any questions with that? So I went a little bit further than what the question asked for, but it's that's why we're here. We're reviewing. So okay. So moving on. Number 6. Find the numbers, if any, at which f has a local maximum. What are the local maxima? So maxima is the plural for maximum. Okay, that's why they use different words.
Mhm.
So we're looking for the local maximum, and they put maxima, but it could be only one, or it could be more than one. So, what would classify as a local maximum?
Where it goes down and it come up to the top.
Yeah. So the y values are the maximum. You're looking at the maximum or minimum. If you look for minimum, you're looking for the minimum or the most negative y values. If you're looking for the maximum, you're looking for the most positive or less negative, depending on where the curve is, y value. And so in this case, the local maximum is what?
The local
Y,
maximum is
yeah.
huh?
The maximum would be y equals, what y value is the maximum y value?
It looked like a one.
Yeah, 1. So the local maximum is 1, and it's at x equal 0. Okay?